Hello everyone. In this video we're gonna do a basic LS-DYNA tutorial. So in our problem we're gonna have a ball impacting on a shell plate. So first of all we're gonna make the shell plate. So to make that we go here, element and mesh, then we go to shape measure, and from here we can choose several options. We click on for and shell. So here we're going to input the coordinate of the four coordinates of the corners of our shell. So I will have 100, 100 and 0. So our shell gonna be in the x and y direction. In 0 we don't have anything. So from here I put minus 100, 100, 0, the second point. The third point gonna be minus 100, minus 100, and the last point gonna be 100 and minus 100. Okay, then this number of elements I'm gonna choose, let's say, is 100, and here also 100, so it's equally distributed. The name of the material of this part, let's say it is a plate. Create. So we have this plate. Okay, done. Now again I click on element and mesh, and then I click shape measure, then I go, and this time I will do the bullet or the projectile, and I take select sphere solid. Okay, the radius of this sphere, let's say it's 15 mm, and the density is 10. Okay, if I do this right now, you can see it's in the middle of the plate. So what I do, I cancel, then I shift in the Z direction, I put it 20 mm. Here I rename it as ball or projectile or whatever you want to name it, and create. So now we have the projectile here, and accept. So now we have the plate and we have the projectile. Okay, next thing to do, we're gonna define the materials of these two. So we go to element from here, element and mesh, and sorry, model and part, then keyword manager, or from here element and part and keyword manager. Here I can define the keyword or the keywords that I need in this problem. So I click on all, then I go to MAT, stands for material. So I need to define the material for these two. So for the ball, for the plate, it will be aluminum. I have a lot of material models here. You can read in the keyword, in the material keyword, in the material what we call it. You can read more about this in the material guide. You can read more about this in the LS-DYNA material guide, or you can read more about these materials in the user manual. So here for this problem I will choose material number 18. So material number 18 is power low plasticity, so I double click on that. I click on add. Here I say aluminum. The density will be 2.685 E minus 6. This modulus, Young modulus, will be 68.95. Gigapascal. Poisson's ratio 0.33. This K and N, the strength coefficient and hardening coefficient. You can refer to the manual for more information about these two values. What do they mean? This, it will be 0.0, 974, and this one would be 0.33587. And here, this is a very important one. We need it because the material in this in our problem, we need, or we want the plate to fail. So the failure strain will be 0.4876, and that's all. This one, leave it at 0. The rest, don't play with it, and click on accept. So now we have the first material. Now second, the material for the ball. The ball will be rigid. We don't want it to deform. We only want to see the deformation of this plate. So in rigid, I click add. Then in the title, I say steel. Okay, the density 6.8 E minus 6. This one, kilogram per millimeter cube. This is 200, and Poisson's ratio 0.3. This is all what we need to define. The rest, just leave it like that. Don't play with them. Accept. Then that's all for the material. So I go up, I close this one. Now I need to define the section. Okay, the section for this plate and this ball or projectile. What does the section mean? Okay, here, let's say for the shell, we have many type of shell elements. It can be 4 points or 3 points, and also what is the thickness of this shell element. So this is what we need to define in this section. So under section, I double click here, and I go down to shell. I click on add, then I say shell section. Okay, so this one, leave it there. This number of integration point, just put 4. The more the numbers, the more result you'll get, the better the results that you will get. So the thickness, let's say it is 0.1, and sorry, 0.1. Okay, then click on enter. All of them will become 1. Then accept. Alright, now we done define the section for this one, for the plate. Now to define the section of the shell, for the ball or the projectile, this one we make it a solid. So we need to put here, we need to take this one, solid, and here just add and say solid section, and hit the accept. Done. Okay, right now what we did, we defined the materials and we defined the section, but we did not link them to these two guys. So for to do that, we go to part, double click, and or click the symbol here, the list will appear, and you click on part. Now we have the plate and we have the ball that we defined just now. Okay, so we need to tell the software that this plate is from the aluminum material and made from the shell section. So here I click on this one, this button, then I click on shell section, then done. For the material also same, I click here on this button, then I click on aluminum, then accept. Now ball or projectile, the section ID is a solid section and material ID is steel, rigid steel, accept. Okay, now done. Alright, so the next one is to define the velocity. So I need to define the velocity of this guy, right? So that can be done many ways. I will choose here initial velocity generation. This is the one that is used commonly used. So here the S type, the slave type, meaning I want to apply this velocity on a node or on a set on a part. So here I click, I see set part ID or set nodal. So I click on 2 because I want to apply the velocity on a whole part, and I click on this node, and I have ball, plate and ball. Of course I choose ball. Okay, let's say if I click on one, I click here, it says no set part is available. Okay, so just move it back, change it back to 2. Okay, now the velocity, it will be minus 20. This will be minus 20 meter per second or millimeter per millisecond. So why I put negative? Because you can see the ball is up here, so I needed to move in the negative z direction. Then hit on the accept. Alright. Okay, now I define the velocity, define the material. Now I need to fix this guy. Of course I will not fix it anywhere, I'll just fix it on the side. So here I click on this arrow, I choose top view. Okay, here I click on shift and hit the scroll, or hold the scroll to move, or I hold the shift button and use the scroll to zoom in and zoom out. Alright, now I want to fix these edges. So how can I do that? There are many ways. I will try from here this command, which is create entity boundary SPC. Alright, so and I click on create, CRE, or create. So these all are ticked, meaning whatever nodes I will choose now, it will be fixed in the 3 direction and also in the rotational 3 direction. Okay, you see here you notice select nodes. So what is the method of selecting the nodes? I can select by node, or I can select by element, many ways. So here I clear, I need to select all the edges, so I click here by edge, then click on propagate. So now if I click on one edge, the selection will propagate. So I'll do the same for the other edges. Sorry, wrong edge. So I click with the right click to cancel, again right click to cancel. Okay, I click this one, right. Now here this guy and then this guy. Now it's nicely fixed, and don't forget to click on apply. Okay, so show, or can show all of them, or none, cancel, yeah, or hide it. Okay, so now almost done. The ball will move, the plate is fixed at the side. Now I need to define the interaction between the ball and the plate. That is done using the contact command. So from here, double click. Usually the most commonly used one is automatic surface to surface. Okay, so click on add, then ball to plate. This is the name. The title, all the titles are optional, you don't need to define it, but if you define it, it's better so that you don't get confused when you open the file later. Okay, so what is the slave and what is the master? Okay, the master is the part that is staying or not moving, and the slave is the one that moves. So as you can see in our problem, the ball will move and hit the plate. So the ball is the slave and the master is the plate. Okay, so again here I have selection type or slave type. Here I have the master type. Okay, what is the master? The master in our place is the plate, which is a part. So I change this one to number 3, and here the slave is also a part, so I change to number 3. So here the master, I click on this dot and I choose the plate, and the slave I choose the ball. Okay, so here the static coefficient I put 0.2, sorry, the static friction coefficient 0.2 and the dynamic one 0.1, and click on accept. Done. Okay, almost done. 2 or 3 more steps. So now I go to control and termination. This one because I need to define the duration of this simulation. So termination, I put it 10 milliseconds and accept. And our last step is to define the output. Define the output is from database. Okay, we have many options, but the very basic one, you just click on binary D3 plot. So here I define the intervals of the plots, which is 0.1. So each 0.1 millisecond we will have a plot. So accept, done, and done. Then I think that's all. Now I want to save this one. So save keyword file as browse. Okay, I have the desktop. This is the folder. Make a new folder, and here I put impact. Then save. Done. Okay, now I click on LS-DYNA. I want to run this. I want to solve this problem. Click on this arrow, then browse, new folder. This is the file that we just did just now. Open. Okay, this is changed to 8. These two parameters depend on the power of your computer. And run. Okay, it will take only 2 minutes. You can see here shell element failed, meaning some of the shell elements are failing and there is penetration through the plate. Okay, almost done. 8 milliseconds, 9 milliseconds. Actually, okay, now it's done. Normal termination. We close this one. Okay, now here are the results. When you want to run the results, you click on this one, D3 plot, or simply you can click on this one, which will open you the last thing that you solved, the last problem that you solved. Okay, here. Okay, now you rotate, hold the shift button and also hold the left mouse button, okay, to rotate. Now you can make it slower, then you forward play. Okay, so you can see the penetration, the ball hitting the plate and the element fails. Okay, here you can control the speed. Okay, if I move this cursor to fast, F for fast, it will go fast, and if I move to the other side, it will be very slow. Depends on how fast you want the result to be displayed. Okay, now we go here to post-processing. Click on this one. You can see the stresses: X stress, Y stress, plastic strain. Okay, the pressure, you can view many things here. Okay, what else you can find here on the history? you can plot many things, like let's say I go to parts and I go to rigid body velocity. Here I can click on the ball. I want to see the velocity of the ball, and click here on plot. So you can see initially the velocity of the ball is 20 meter per second or millimeter per millisecond. Then as it hit the plate, it goes down, then it penetrates, it moves at constant speed. And also other things that you can plot here is, let's say, click down, no, click up here, total part energy. So you can see plot here, this is the energy of the ball. You click on the plate, you can see this is the energy of the plate. For initially it's 0, then as the ball hits it, it absorbs some of the energy. Okay, so that's all for the first tutorial. I hope you benefit from it, and see you next time.